All right. Greetings. Welcome in. Welcome to my channel. Uh, Happy Monday. I hope everyone is doing well. And I am doing another live stream for math. If you have a math problem that you would like to see worked, please post in chat and I will do my best. In the meantime, I'm going to be working on my board again, as usual, and yeah, seeing if I can have some success up here. What I plan on doing today is just introducing the row reduction process and solving. And so what I want to do is I want to use the same system and basically get it set up for Gauss-Jordan elimination. And yeah, so hopefully I won't be up here very long unless I catch students. If I do catch a student, then I'll be up here longer, but otherwise I'm planning on maybe 30-minute live stream today. And yeah, so I'll just go ahead and get right into it. And I'm going to go ahead and erase. I don't know why as soon as I want to go live, I had all of a sudden have all these technical issues. So with a lot to being able to open up this space, and I am trying to discipline myself to come Monday through Friday and keep my schedule, and that was challenging in itself because of the goings on in the day. Just every day presents a new set of circumstances that you have to deal with, and makes it challenging. So we'll keep the heading, we'll keep the system, and we're going to be using matrices. However, this is a different method of solving. And rather than using an inverse matrix, what we're doing is we're using the identity matrix. So what we're going to do is we're going to augment the coefficient matrix with the identity matrix. And then we're going to perform a set of rules. And we'll write them down. There's 3 main rules. And so we'll just go ahead and augment the matrix and then we'll talk about them. That's probably good enough. All right, so we have this system and we have a solution to this system. So what we're going to do is we're going to start out with the coefficient matrix. And let's go ahead and see if we can just get it right in here below. Get it set up. And recall, I am just taking the coefficients of this matrix and let's see how it works. 3, 2, -4, -6, 3, -7, -15, 9, -17. And I think I need my constants in here. So it's been a while since I've done this. So I'm pretty sure that we're not going to use the coefficient matrix. It's just we're going to use the coefficients, not the constants. And then what we're going to do is we're going to attach it to the identity matrix. And identity matrix is the one only consisting of ones and zeros. So we have a 1, 0, 0, 0, 1, 0, 0, 0, 1. And what we're going to do is, this is the identity matrix. What we want is we want to end up with the identity matrix on this side and just some numbers on this side. And when we do that, we have essentially solved the system. So this process is called augmenting a matrix. And yes, I could make a mistake at any point in time. So let's go ahead and go over the rules. The first rule is, in order to get, so what you want is you want this essentially over here after you've performed a series of like operations on it and steps. So the rules, basically you can swap out. So rule number one, you can swap, and essentially you can change the order of switch the rows out. So we'll say swap out any rows. Rule number two is you can multiply a row by a scalar. And then rule number three is you can add any two rows. So those are the basically main rules. And then what I plan on doing is just spending maybe some time. This is very, very complicated for me. And yeah, so it's not the funnest, like, unless you have time. It's fun for me to do if I have plenty of time to do it. This is something that you would probably train a computer to do and then have the computer do it because of the speed and everything. So what I want to do is just take a moment to look at it and see what the goal is to be able to solve it in as few steps as possible. And I'm going to make sure that I have it set up right. I'm just taking my time. I practiced this a few weeks ago, back when I got my linear algebra book out. And then I decided that I would like to work one of these up here eventually. And then my experience is getting me, because now I'm not even confident I haven't set it up correctly, but All right, so let's go ahead and multiply. What we'll do is we can multiply row 2 by 2, and then we're going to add it to row 3. And then we will replace row 3. Let's do that. So this is 2. And so what you do is you keep track of, so you say 2 times row 2 plus row 3, essentially. So each one of these values is going to get multiplied by 2. So we'll start by just rewriting this system out. So it's -3, -6, -15, 1, 0, 0, because row 1 is not being touched. So we're just going to rewrite it in its entirety. And row 2 is not going to get touched either. So we'll just repeat that one. So we're going to multiply it though. It's going to change. It's getting quantified by that scalar. So it's 4, 2 times 3 is 6, 2 times 9 is 18, 2 times 0 is 0, 2 times 1 is 2, and 2 times 0 is 0. And then instead of writing row 3, what we're going to do is we're going to add this scaled amount to row 3 and then replace row 3. So we have 4 minus 4 is 0, 6 plus -7 is -1, 18 plus -17 is 1, and then see, 0 plus 0 is 0, 2 plus 0 is 2, and 0 plus 1 is 1. So that's a very good first step, because we have, if you notice here, we have 0, 0, 1. We have, all we need is this one to become 0. And I think what we'll do next is we could just possibly add these 2 rows. We'll add these 2 rows, we'll replace it with row 1, and see where that goes. And again, this is a very complicated process, so what I'm hoping is that maybe I'll work on this one in my spare time and come back tomorrow and show it in as few steps as possible. And by what I mean by few is not many. All right, so let's go ahead and just add these 2. So we'll go ahead and try and keep track of our operations. So the next one, here, we use proper English and just do semicolon here. We're going to plus row. Let's see, that's not how I'm gonna write it. So row 1 plus row 2. And we'll replace row 1, I think is what I said. So 4 plus -3 is 1. 6 plus -6 is 0. 18 plus -5 is 3. 0 plus 1 is 1. 2 plus 0 is 2. 0 plus 0 is 0. And so we've got, let's see, 4, 6, 18, 0, 2, 0. And this one's 0, -1, 1, 0, 2, 0. Just kidding, that was a 1. Right. And again, it is a little bit scary up here for me because I'm doing math that I have not reversed. However, just trying to remain transparent. I don't want to be so transparent that I'm see-through, completely clear, but I do want to be transparent in the math for sure. So I am fine up here, just being myself. And people that know me know that I'm not going to ever be scripted. I don't think that I would be able to follow a script, even if I tried like really hard. I mean, if I trained for years, I wouldn't be able to follow that script. So it's just it's not in the cards, unfortunately. So I really have to just embrace who I am. So, and it's Monday and I'm here. So I showed up and I'm present. And so I really feel like I can't beat myself up too bad. My live stream Friday, I was pretty rough on myself. So we have to kind of flow and then go, right? All right, so I'm over here. Let me think about it for just a minute, see if I see a really good next step. And going back through my linear algebra book, there are many, many ways to solve these using matrices. So I really feel like maybe I should just start on page 1 after this one. And yeah, this is just a thought I have right now. Is to just start on page 1 and go through all of the examples. That would be cool. All right, so I really want this row, this position right here to be 0. So if I take row 2 and multiply it by the scalar 1/6 and then add to row, let's see, I can add that to row 3, replace row 3. So let's do that. So I'm going to say 1/6 row 2 plus row 3. And try to keep track of all my operations this way. And we can go ahead and fit another one in here, I think. So here I am writing upside down and backwards again. Great. Six. So 1/6 times 4 is going to reduce down to 2/3. So we'll say, we'll go ahead and write that first row, 1, 0, 3, 1, 2, 0. And let me do a little bit better job. 1, 0, 3, 1, 2, 0. And I've got 2/3. And 1/6 times 6 is 1. 18 divided by 6 is 3. 1/6 times 0 is 0. 1/6 times 2 is 1/3. And then 1/6 times 0 is 0. And then I believe I said I was going to add it to row 3 and replace row 3. So let's go ahead and add these two rows together. So we've got 0 plus 2/3 is 2/3. And -1 plus 1 is 0. One plus 3 is 4. Right. Yeah, we're replacing row 3, right? Instead of replacing row 3, let's go ahead and add it and replace row 2. See what happens. Because we've already got this 0, -1, 1. All right, never mind. We'll just do it in the next step. Again, we're 25 minutes in. I only want to do at least 30 minutes of this. So I really don't, I'm not going to spend an hour doing this. If it was scripted, I know exactly what to do, that I would, but we'll just say, this got to ruin my 0 now there, but that's okay. So we got 0 plus 2/3 is 2/3. -1 plus 1 is 0. 1 plus 3 is 4. 0 plus 0 is 0. 2 plus 1/3, so that's going to be 6/3 plus 1/3 is 7/3. And 1 plus 0 is 1. I'm trying to keep the rows organized. We've almost got all of the 1s in place, but we really need 0s now. So let's do a couple more steps. And it looks like we're gonna have to multiply either row 2 or 3 by -1, and then re-add. So I'll tell you what, let's multiply row 2 by -1, and then we're going to add it first to row 1, and then we'll replace row 2. Let's do that. So we're going to say row -1, row 2, plus we'll say plus row 3. Just like that. It'll turn this one into 1. Let's just go with it. So let's just go with it. See what happens. So we've got, we're going to not write row 1 because we're going to replace row 1. This is me up here not being 100% confident, but all right. So -1 row 2 plus row 1, replace row 1. So we'll go ahead and do row 2 and 3. So 2/3, 0, 4, 0, 7/3, 1. And then this is -2/3, -1, -3, 0, -1/3, 0. And then we're going to add to row 1, replace row 1. So we've got 1 minus 2/3, so 2 over 2 minus, 3 over 3 minus 2 over 3 is 1 over 3. 1/3. So these two, this is going to become a -1. That's going to become 0. That's going to become a 1. 6 over 3 minus 1 over 3 is 5/3. And we got 0, and 0 is still 0. All right. So, all right. And then we can make this one 0 again really quick if we wanted to. So let's do that. We're going to just add, we're just going to add row 2 plus row 3. And maybe just 2 more steps and then we'll stop. And then I will work on this some more. And maybe a little too much. like improv, like honestly, because I probably should spend more time thinking about it. I literally just decided what I was gonna do, maybe you know, an hour before my live stream, so it's probably not the best, but it is what it is. So, all right. We've got row 2 plus row 3, and then do we want to replace row 2 or row 3? How to decide that? Let's go ahead and copy down row 1. 1/3, -1, 0, 1, 5/3, 0, and -2/3, -1, -3, 0, -1/3, 0, and we'll replace row 3. So we've got 2/3 plus -2/3 is 0. And then 0, -1 plus 0 is -1. 4 plus a -3 is 1. 0 plus 0 is 0. 7/3 minus 1/3 is 6/3, which is 2. And then 1 plus 0 is 1. All right. And then one more step. I wonder what the best thing to do is here. Well, I guess we could multiply row, let's see. We could let's multiply row 1 by 3 and multiply row 2 by, let's see, multiply by 3. And then this is where reciprocals really come in handy. We're going to multiply row 2 by 3, and then we'll multiply row 2 by 3 over 2 and add them. So we'll multiply, so it's 3 times row 1 plus 3 over 2 row 2. And then I have to decide which one I want to replace. So we'll go ahead and rewrite row 3, -1, 1, 0, 2, 1. And then we're going to say 3 over 2 and 3. And we're going to add them together. And then which one do we want to replace real quick? We'll replace row 2 since there's not any zeros. And see where that gets us. So we're going to go ahead and rewrite row 1 with a new scalar. 3 times, oops, that's a mistake. And this is where mistakes happen a lot. I've noticed in my work anyway. So 3 times 1/3 is 1. 3 times -1 is -3. 3 times 0 is 0. 3 times 1 is 3. 3 times 5 is 15/3, which is 5. 3 times 0 is 0. And so we're going to have to do mental math. So that's 1 -1, which is 0. And then 3/2 times -1 is -3/2 minus 2/2. That's -5/2. And then 3/2 times -3 is going to be -9/2 plus 0. -9/2. 3/2 times 0 is 0. 3/2 times 1/3 is -3/6, which reduces down to -1/2. And 3/2 times 0 is 0. Okay, good. And this is as far as we've gotten. And as I promised, we're 30 minutes in, approximately 32 and counting. So let's go ahead and stop there. We'll table it. And I will try really hard to work on this in my spare time and come up with a solution for this method, making sure that I'm working it correctly. And yeah, well, I can use some of my spare time on my clipboard. It's a lot easier to work these on paper than it is on the board, obviously. But yeah, I just wanted to show up today and kind of introduce another way of solving them through matrices. And yeah, so it's important for me to show up every day and work on my math. So that's what I'm trying to do. And so we'll go ahead and end there. I hope everyone has an amazing rest of their Monday evening. And as a reminder, we'll be back tomorrow between 6 and 7 p.m. Central Time. Just hanging out on my board, offering up this space. So if anyone wants to come hang out with me and do some math, then you're more than welcome to do that. And I will sign off and I will say bye for now. I will see you next time.